Okay, this is 8.3, properties of angles in a circle. We're going to learn about arcs in a circle. So the shorter arc is the minor arc and the longer arc is the major arc. The angle formed by joining the endpoints of an arc to the center of the circle is a central angle. So right here is our central angle. The angle formed by joining the endpoints of an arc to a point on the circle is an inscribed angle. So that is our inscribed angle. The inscribed and central angles are subtended by the minor arc. So if we have a central angle and an inscribed angle, we know that the measure will be double or half. So if we look at angle R in relation to angle O, this should be half of what angle O is. And similarly, this should be double of what angle O is. That'll make more sense when we start working with it. And it is because they are subtended by this arc. That means they both exist within the same arc. In a circle, all inscribed angles subtended by the same arc are congruent, which means that they are equal. So this one's equal, and this one's equal. Okay. Our last property, angles in a semicircle. So all inscribed angles subtended by the same semicircle, so if it is exactly half, are all right angles. So this is exactly 180 degrees, so we have right angle, right angle, right angle. Using inscribed and central angles, like I said, it is easiest just to jump in. These are going to be kind of more logic-based questions, so just follow along slowly. Point O is the center of a circle. Determine the values of angle X and angle Y. So if we look, we see that angle D and angle C are inscribed. And subtended. By the same arc. Therefore, angle D equals angle C. Because we talked about how if they're subtended by the same arc, and they're on the same arc here, and they're inscribed angles, which they are, they should be congruent. So then x degrees is equal to 55 degrees. Now, if we look at angle O, or y degrees, and we have angle C here, that's the only other angle that we know. We have our minor arc of, oh, that's a little too far. Our minor arc of AB, we can see that angle O is equal to twice of the angle C. And it's because of this minor arc. So then, therefore, y degrees is equal to 55 degrees times 2. Y degrees is equal to 110 degrees. Okay. All right, so applying the properties of an angle inscribed in a semicircle. So rectangle ABCD has vertices on a circle with radius 8.5. So we know that if we extend this, that this should be 17. The width of the rectangle is 10 centimeters. So 10 centimeters, 10 centimeters. What is its length? The really nice thing about this is that we don't really need the property of an angle inscribed in a semicircle beyond the fact that we know that these should be equal. So if we look, this just becomes a nice, easy Pythagorean theory problem. So the square root of 17 squared minus 10 squared is equal to x. The square root of 189 is equal equal to x, and it says to the nearest tenth, so 13.7 centimeters equals x. Determining the angles in an inscribed triangle. Oh, this one will be interesting. So the first thing that I want to deal with is right here. That is a circle. The value of the amount of degrees that is in a circle is 360. So if we're dealing with x degrees, it equals 360 minus 100 minus 140 to give us 120 degrees. Done. Let's look at our next one. We have angle B, and angle O would probably be our next one. So these guys are subtended. So angle B is inscribed. Angle O is the central. These guys are on the same arc. Therefore, y degrees is equal to 1/2 of angle O. So 1/2 of 120 degrees, which gives us 60 degrees. And our last one, if we look, we have angle Z. So, cool thing about this, when I draw out this triangle, angle X is up here, so that's 120 degrees. And then we should know, because of how this bisects, that we are dealing with an isosceles triangle. We have 120, so we have our oblique angle, we have sides that would be equal. These are equal, these are the radius. And because we have two legs that are equal and an oblique angle, our angles here should be equal to each other. So it's 180 minus 120, which is equal to 60. So Z is equal to 1/2 of 60 degrees, which gives us 30 degrees for each Z. Hey, your assignment is down below. If you have any questions, please let me know. If you flip ahead, there's a project. I want you just to make a poster that summarizes the properties of angles in a circle. So this is kind of like a personal cheat sheet. Shouldn't be bigger than 1 page. If you have any questions, please let me know.